talking about today. The amazing world of navigational aids in civil aviation. Get ready to have your minds blown because some of this stuff is seriously next level. First up, we're talking about the VHF Omnidirectional Range Station, or VOR for short. Think of it like a giant, super-powered compass in the sky, but instead of pointing north, it points to the station itself. These ground-based stations send out radio signals in every direction, like a beacon in the night. Pilots use a receiver in the cockpit to pick up these signals and figure out their position relative to the VOR station. It's like having a virtual signpost in the sky telling you exactly where you are and what direction to go. Pretty cool, right? Now, here's a fun fact. Did you know there are over 3,000 VOR stations scattered across the globe? That's a whole lot of navigational power. These stations are crucial for pilots, especially when they're flying in areas without fancy GPS coverage. Okay, so how does it actually work? Well, each VOR station transmits a unique signal that acts like a radio fingerprint. The receiver on the plane picks up this signal and compares it to a database of all the VOR stations and their locations. By analyzing the phase difference between the signals, the receiver can pinpoint the plane's exact bearing from the station. Think of it like this. Imagine you're standing in a field with two friends, each holding a flashing light. If you know the timing difference between the flashes, you can triangulate your position. VORs work in a similar way. All right, moving on to another crucial piece of aviation tech, radar. Now, you've probably heard of radar before, but did you know there are actually two types used in aviation? First up, we've got primary radar, which is like the OG of aircraft detection. This system works by sending out powerful radio waves from a giant rotating antenna, like the ones you see at airports. These waves travel through the air until they hit something solid, like an airplane. When that happens, the waves bounce back to the antenna, and boom! The radar system detects the aircraft's location. It's like playing a giant game of electromagnetic Marco Polo. Primary radar is super useful for air traffic control because it can detect any aircraft within its range, even if they don't want to be seen. Next up, secondary radar. It's more sophisticated. It uses a transponder, a radio receiver and transmitter. The radar sends a signal. The transponder replies with coded data. Information includes altitude, speed, and identification code. This makes secondary radar accurate. Controllers rely on it. It maintains safe separation and manages busy skies. VOR, the trusty old compass of the sky. Imagine a world before GPS. Pilots relied on NDB, the aviation lighthouse. ADF points to NDB, like a compass. Why are NDBs still around? They're incredibly reliable, not affected by bad weather or mountains, cheap to install and maintain, good for remote or developing areas. But they have limitations. No distance information, only direction. Pilots estimate speed and time, signals can be distorted, atmospheric bending affects accuracy, ADF needle can be jumpy. Landing a plane requires precision guidance. ILS guides pilots safely to the runway, even in near-zero visibility conditions. It's like landing with your eyes closed, much safer. ILS isn't just one big piece of equipment. Several components work together for a safe landing. Localizer projects the runway centerline into the sky. It helps pilots line up perfectly with the runway. Glide slope is an invisible ramp descending at a specific angle. It maintains the correct descent rate. Marker beacons are checkpoints along the approach path. They emit distinct sounds in the cockpit. Approach lighting system provides visual cues for final landing. GPS is a game changer, folks. It uses satellites to pinpoint your location. Pilots get real-time latitude, longitude, and altitude. GPS unlocks new flexibility and efficiency in air travel. Pilots can fly more direct routes, saving time and fuel. GPS helps navigate around bad weather and congested airspace. It also enhances safety by alerting air traffic control. In emergencies, GPS aids in faster search and rescue. Area navigation, or RNAV, allows planes to fly direct routes. Shorter flight times, less fuel, smaller carbon footprint. RNP is like a super precise GPS. It ensures pinpoint accuracy in challenging environments, enhances safety and efficiency in airspace. You know those flashing lights you sometimes see on top of tall structures? No, not the ones on cell phone towers, although those are important too. I'm talking about aerodrome beacons, those trusty lights that have been guiding pilots to airports for decades. Imagine flying at night, or in bad weather with limited visibility. You need a clear visual cue to tell you where the airport is located. That's where aerodrome beacons come in. They're like giant, flashing welcome signs for pilots. These beacons emit a powerful beam of light that rotates, creating a distinctive flashing pattern. The color and sequence of the flashes provide pilots with information about the type of airport and its operational status. Now you might think, in this age of GPS and advanced navigation systems, do we really still need these old-school beacons? Well, the answer is a resounding yes. While modern technology has certainly revolutionized aviation, there's something to be said about the simplicity and reliability of a good old-fashioned light beacon. They don't require any complex electronics or external signals. They just work. Plus, they act as a visual backup in case of any issues with the primary navigation systems. Remember, redundancy is key in aviation safety. So next time you're near an airport, keep an eye out for those flashing beacons. They're a testament to the enduring power of simple yet effective technology. From the groundbreaking VOR stations to the timeless NDBs and cutting-edge GPS technology, navigational aids ensure that aviation remains the safest mode of transportation. So next time you board a plane, take a moment to appreciate the technology working silently to keep you safe in the skies. If you found this video fascinating, don't forget to like, subscribe, and hit the bell icon for more amazing content about the world of aviation. See you in the next video.